At this point in history, we have a rise of agentic children. When it comes to the world of raising the agentic child, most people have no idea what to do. You reproduced it for the pleasure, and now you have to deal with the consequences. Most of you don't know how to set guidelines, or even how to feed them. You have no parent-child relationship, just kids raising kids, as they destroy your business, embarrass you in public, and lie to you. But if you are one of those parents, there is hope. This is one video in a series of videos about the proper care and feeding of the agentic child. Because if you spare the rod, you spoil the child. Hello world and welcome back to my channel. Today we are focusing on a topic called soft optimization. What is soft optimization? Soft optimization is a lot like training a human in a new job. The person may have some general pre-trained life experience and education. Take a new hire coffee barista for example. Regardless of the person's background, they still need to be trained on how to operate as a barista, with documented knowledge references like understanding the employee handbook, how to work the register, make coffee products, troubleshoot common problems, and deal with customers, and other standard operating procedures. Today we're diving into something that's both cutting edge and practical, training and evaluating the agentic agent with soft optimization. If you've been hearing the buzzword Agentic AI and wondering how it actually works, then check out this video here. Let's start with the basics. Agentic AI is about moving beyond a single large model into a system of intelligent agents that can manage tasks, query data, and orchestrate workflows with autonomy. Let's say I have a fully automated coffee shop where the customer can communicate via electronic means. It can process payments, output receipts, update the books, and send the order to the auto coffee maker, which outputs a fresh cup of coffee in the vending machine for the customer to grab. When we use a large language model like ChatGPT to operate this information system workflow, we can refer to this automated coffee shop as an agentic agent. Testing the agentic agent is a multi-layered evaluation. You start with a unit-level large language model, then check integration or agent handoffs, then push for robustness under stress, and finally, measure system-level metrics. There are two types of optimization methods. Hard optimization, which is internal optimization, is locked for closed-source large language models such as OpenAI's ChatGPT, Anthropic's Claude, or Google's Gemini. They do not allow end users to directly modify their internal architectures, parameters, or training weights. These components are proprietary and controlled exclusively by the model developers. Hard optimization is like changing someone's DNA. As a result, hard optimization at the model level is not available to outside users. Luckily for you, there is soft optimization. Soft optimization is a practical way you can tune a large language model without ever touching the internal architecture. This means guiding the model's behavior without touching the weights or the DNA. Soft optimization is like training your new barista. You can't change their genome, but you can sharpen their skills, set boundaries, and pump them full of performance-enhancing drugs, like clean data, sharp prompts, and tighter guardrails. That's how agentic AI systems scale. The most important step of optimizing any machine learning model is to clean your data. Garbage in is garbage out. And if you don't know how to clean data, then check out this video on data cleaning here. Now we're going to be covering the core techniques of soft optimization. There is prompt engineering. This is the most direct form of soft optimization. By rephrasing your prompt, setting clear instructions, or using few examples, you drastically change the quality of the outputs. Importantly, any data that's cleaned and in tabular structure is the most superior form of prompt engineering. Therefore, a retrieval augmented generation or RAG database is necessary instead of relying on the model's memory. For example, putting the coffee shop employee handbook and the SOPs in the database for the new hire to reference. Guardrails and orchestration. This means setting rules around the model. For example, blocking unsafe outputs, rerouting certain tasks to different agents, or using multiple models in a pipeline. Think of it as giving the model boundaries and teammates. Setting guardrails is good practice of data governance. A good example of a guardrail would be creating an additional data pre-processing and cleaning script after an auto web scraping function prior to updating a RAG database. When we talk about training a large language model, there are two flavors: pre-training or fine-tuning. This involves feeding the model domain-specific data to specialize it. For example, giving it an employee handbook, SOPs, or other clean data. Then there's instructional tuning and alignment. This is teaching the model how to respond inside of the agentic framework. For example, a large language model agent learns to summarize the customer order, then pass the results to an order generation system. In short, training ensures your large language model speaks the language of your domain and plays well with other agents. Once trained, we test, but not just with random prompts. In Agentic AI, testing means prompting questions from a test on the subject matter and manually scoring it. Running benchmark tasks such as classification, Q&A, summarization, and reasoning. Checking chain of thought interactions between agents. Does the planner hand off the task correctly? Does the retriever fetch the relevant data? Measuring robustness. What happens if the user input is noisy or adversarial? This step ensures your model doesn't just know stuff, but can actually function reliably inside of the agentic system and be able to generalize well on unseen data. Now comes scoring. In Agentic AI, scoring isn't just accuracy, it's multidimensional. Things such as performance metrics, efficiency metrics, and trust and safety metrics. Performance metrics are getting accuracy based on tedious human testing and scoring. Efficiency metrics are latency, cost per query, and token usage. Trust and safety metrics include bias detection, hallucination rates, and compliance with policies. Some systems even add feedback loops where one agent scores another agent's outputs. This allows self-correction and continuous improvement. However, pause for effect. These feedback loops are lazy and are prone to just transferring garbage from one machine to another and not giving you any accuracy at all. There's also chain of thought agent interaction, such as integration testing. Sometimes the agent just isn't the model spitting out text, it's a coordination of multiple agents, a planner, retriever, executor, evaluator. We evaluate the planner or retriever handoff. Did the planner generate the retrieval query that makes sense? Then we focus on the retriever to the large language model. Is the retriever surfacing relevant documents, or are we feeding garbage to the large language model? Then we have the large language model to the executor. When the model outputs code or actions, does the executor actually run them without errors? This is like API integration testing in software engineering, making sure the interfaces work between agents and not just individual pieces. Then we go into robustness and stress testing or adversarial testing. Even if your large language model performs well in normal cases, you need to push it to failure deliberately with noisy inputs such as misspelling, slang, extra pronunciation, adversarial prompts such as jailbreak attempts, prompt injection, and conflicting instructions, and edge cases such as long documents, empty queries, ambiguous wording. Here you are probing for system resilience. Does the large language model degrade gracefully, or does it produce unsafe, nonsensical, or just useless outputs? Then we measure system level metrics. Finally, you measure end-to-end performance across tasks. Task success rate. Did the system achieve correct outcome? Latency distribution. How long does the multi-agent flow take compared to a single LLM call? And failure mode analysis. Where do errors occur the most? In planning, retrieval, execution, or generation. This gives you a diagnostic view of how the system holds up in production-like conditions. Putting it all together, here's the scoring framework in a nutshell. Performance metrics measure quality, efficiency metrics measure practicality, and trust and safety metrics measure reliability. We train our LLM to specialize, we test it with real-world workflows with other agents, and we score it across multiple dimensions, not just accuracy, but reliability, efficiency, and trust. So remember, hard optimization is tweaking the model's weights. That's closed off to you unless you work for Anthropic or OpenAI. But for everybody else, there is soft optimization. And that's tweaking everything around the model. That's open to you and me, and a necessary part after hard optimization. And if you want to learn about hard optimization with open source models, then check out this next video here.